Hi everyone, Assalamualaikum. In this video, we will discuss integration of inverse trigonometric functions. Okay. Alright, now we recall back what inside inverse trigonometric function. First, we done discuss the introduction containing notation, graph and the useful formula of inverse trigonometric functions. And after that, we continue with how to evaluate inverse trigo functions using triangle method and followed by derivatives of inverse trigonometric functions. We done discuss number 1, number 2 and number 3. Now, we continue with topic 4 under inverse trigonometric functions, which is integration of inverse trigonometric functions, right? Alright, this section presents some formulas of integration involving inverse trigonometric functions. Alright, we divide the formula by two columns. The first column is formula in general, and the second column is the formula for integration of inverse trigo function that will be given in appendix in final exam papers. Okay. Alright, formula number 1 in general. Integration of 1 over square root of a squared minus u squared du. The answer equals to inverse sine u over a plus c. Okay. Number 2, integration of 1 over a squared plus u squared du. The answer equals to 1 over a inverse tangent u over a plus c. Okay. No square root in denominator. Okay. And in between is plus. Okay. And then number 3, formula for integration of 1 over u square root of u squared minus a squared du. The answer equals to 1 over a inverse sec u over a plus c. Alright. What is a? A means constant. Okay, constant means any value. What is u? U means the function in any variables. Okay. Alright. Now we look at the formula that we given in appendix in final exam. Okay. Formula number 14 is similar to formula number 1, but the symbol is x here, single x. Okay. In general, we better use u because u represent any function, okay, containing variable x or any variables. Okay. And then formula number 15, okay, similar to formula number 2 here. Okay, but the symbol here is x, single x. Okay, in general, we better use u. Okay, because u means any function in terms of x. Okay, and formula number 16 is similar to formula number 3. Okay, but the symbol here is single x, and in general, we use u because u means any function in terms of variables. Alright. Alright, like other integration problems, basic substitution method is applied wherever appropriate. Now, let's go through some examples. Okay, we look at example 1. Evaluate integration of 1 over square root of 3 minus 4x squared dx. Okay. Alright, from the given question here, okay, numerator is constant and denominator inside third symbol or inside square root symbol is quadratic. Means the answer can be either inverse trigo function or inverse hyperbolic function. Okay, we will discuss later inverse hyperbolic function in chapter 2, right? Alright, if the answer will be inverse trigo function, which is numerator equals to constant and denominator inside third symbol is quadratic, so we can write into the form of a squared and u squared. A means constant and u means the function with variable x, right? So from here, we can write 1 over square root of, we write in terms of a squared. So to write in terms of a squared, where a equals to constant, so 3 here, we can write third 3. And then bracket squared, because when we simplify third 3 bracket squared, we will get back 3 here, because this is equal sign. Alright? And then we need to write in terms of u squared. U means the function in variable x. So we can write 4x squared here equals to 2x in bracket squared, because when we expand, we will get back 4x squared. Right? Right, after that, we list down a, u, and then we need to find du over dx. Right? Our a equals to constant, which is third 3. And u equals to the function in variable x, which is 2x. Right? From here. And after that, we need to differentiate u with respect to x. So we get du over dx. And when we differentiate 2x, the answer equals to 2. And after that, when we use u substitution, we need to write dx as a subject. So we will get, from here, we will get du over 2. And after that, we substitute back, okay, in terms of a, u, and du. So we have integration of 1 over a equals to third 3. Okay. And then our u equals to 2x. And dx equals to du over 2. Okay. We substitute a, u, and dx here. Right? So that we will get in terms of a, u, and du. Okay. And after that, we can move out denominator 2. Okay. Outside integration symbol. So we get 1 over 2. Integration of 1 over square root of a squared minus u squared du. Okay, no more over 2 here because we move out here. Okay. And then we can refer from integration of inverse Trigo function. Okay. When we compare with this formula, it is similar to formula number 1. Okay. When we integrate 1 over square root of a squared minus u squared du, the answer equals to inverse sign, u over a plus c. So we can apply here. Okay? We still have half here. And then when we integrate 1 over square root of a squared minus u squared du, the answer equals to inverse sign u over a plus c. Okay? And after that, we replace u and a. So we have half inverse sign, our u equals to 2x, and our a equals to third 3. And then plus c. So this is the final answer when we integrate 1 over square root of 3 minus 4x squared dx. Alright? Alright, now we continue with example 2. Evaluate integration of x squared over square root of 3 minus 4x to the power of 6 dx. From the given question, we can write into the form of integration of x squared over square root of 3 bracket squared minus 2x cubed bracket squared dx. Alright, 3 bracket squared here, after we simplify, we will get back 3 here. And 2x cubed bracket squared here, after we simplify, we will get back 4x to the power of 6 here because it is equal, right? And then numerator has x squared and denominator inside squared here has term containing x cubed. So means that we can relate with derivative. If we can relate with derivative, means we can use u substitution when we integrate. And u, we choose the term containing x cubed because after we differentiate, we will get term containing x squared so that we can simplify x squared here, right? So from here, we write into the form of a squared and u squared. Okay, a means constant, u means term containing x. Okay, that we will differentiate. Okay, alright, so from here our a equals to 3, u equals to 2x cubed, and after that we differentiate u with respect to x, so we get du over dx, which is equals to 6x squared. And when we use u substitution, we need to write dx as the subject. So we get du over 6x squared. And after that, we substitute back into the given question here. Okay, so we write in terms of a, u, and du. So we have integration of x squared over, we replace a equals to 3. Okay, and then we replace u equals to 2x cubed. And then we replace dx equals to du over 6x squared. Right? After that, we can simplify x squared from numerator and x squared from denominator here. Okay? And then at the same time, we can move 6, constant 6 outside integration sign. Okay? We can move constant from integration sign, but never move variables from integration sign. Right? So after we simplify x squared from numerator and denominator, and then we move constant 6 here, we move denominator 6 from the integration sign, we move out here. So we get 1 over 6 integration of 1 over square root of a squared minus u squared du. Alright? And then from here, we can compare with integration of inverse trigo function formula. Okay, so from here we have integration of square root of a squared minus u squared du, and the answer equals to inverse sine u over a plus c. So we can write here, okay, we still have 1 over 6, and then after we integrate 1 over square root of a squared minus u squared du, the answer equals to inverse sine u over a plus c. Right? And then finally, we replace u equals to 2x cubed and a equals to 3. So the final answer equals to 1 over 6 inverse sine 2x cubed over 3 plus c. Okay, this is the final answer when we integrate x squared over 3 minus 4x to the power of 6 dx. Right? Coming up next, examples for integrations of inverse trigonometric functions. Okay, if you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.